All right, sorry I couldn't be there today, but we are taking a look at the SOHCAHTOA homework from page 11, and then we're going to start into finding missing angles here. So for number one, let's give this one a pause, try this one first, and we'll take a look at it in a second. Okay, hopefully you found your reference angle for the first step. Label our sides as adjacent and hypotenuse, and then chose our trig function, which should have been cosine. So cosine of our angle theta is equal to the adjacent over the hypotenuse. And then we're plugging in 51 for our angle measure, x for the adjacent, and 28 for the hypotenuse. So cross multiply here, x equals 28 times the cosine of 51. And then we'll use our calculator. So just 28 trig button next to the 7, cosine. We also want to make sure we're in degrees. So if yours says radian up here, remember to click on the settings wheel, go to document settings, and change that from radians, if it's in that one, to degrees. Go down and you can press the tab button here to shift down to make default. Click enter and then enter so that we're all set. And then 28 times cosine of 51. And then we're going to round to the nearest hundredth, so that would be 17.62. Okay, try number 2 on your own here. Okay, so hopefully we labeled our angle. We have the opposite and adjacent, so we're going to go with tangent here. So tangent, plug in, tangent of 20 equals 15 over x, cross multiply, and then divide out by the tangent of 20 because we're going to be multiplying 20 times the tangent of 20, I should say, times x, and then 15 times 1. So just be careful in there and get 41.21. All right, let's give number 3 a chance here and number 4, and we'll go over those in a second. Okay, so for number 3, should have labeled opposite hypotenuse. What was sine? Plugged in. So got sine of 67 is equal to 3.4 over x, opposite of hypotenuse. Cross multiplied, divided by the sine of 67 to get 3.69. Second question, we have adjacent hypotenuse from our angle. So we're going to go with cosine. We're going to substitute in. So cosine of 59 is equal to 432 over x. Cross multiply once again. Okay, remember we're going to multiply 1 times 432, cosine of 59 times x here, and then divide out by the cosine of 59, and our final answer will be 838.77. For that last one, okay? So that would be our final answer here. So once again, we're going to cross multiply and circle the whole number here, and then divide out by x, or sorry, sine of 67 here. Okay, number 5, hot air balloon tied to the ground, 2 straight ropes. One of them is on the diagram below going diagonally, one's going to the ground. The other rope, which is 110 feet, is forming a 50-degree angle. So we want to figure out 2 things. What is the height of the balloon directly over the ground? So this is part A, we'll call this A. And the distance between the 2 ropes, which we'll call this B here, okay? So for A, we're going to have to use SOHCAHTOA because we have an angle in one side. So we want to label our sides. We have A, which is opposite from 50, and our hypotenuse. So remember, for our SOHCAHTOA, we're going to choose sine here for opposite and hypotenuse. Let's see if you can set this up and solve the first one. Okay, so we have a couple options here. Number 1, we want to figure out the measure of A. So we're going to use sine to do this one. So sine of 50 equals opposite over hypotenuse. So that's A over 110. Cross multiply here to get 110 times the sine of 50 equals A, which gives us approximately 84 when we round to the nearest foot. Now for part B, there's one of 2 ways you can do this. Option number 1, you can use the Pythagorean Theorem. Remember we talked about that c squared minus b squared formula. So 100 squared minus 84 squared is 5,044, and the square root gives us 71. There's a second option though, because we still have the angle measure, and we're looking for a side, we can also use cosine here. Okay, so that side where the ground is would be the adjacent to our hypotenuse of 110. So cosine of 50 would equal b over 110, and we cross multiply, we'll also get 71 feet for our final answer. So either method will get you the same answer here. Just make sure we're rounding to the nearest foot. All right, we're going to continue on here and take a look at our day 3, which is finding missing angles. So just a real quick, just think for a second about how you'd solve both of these questions, A and B. Okay, hopefully you're recognizing that for A, you're going to undo the multiplication of 2 and x by using the opposite operation, right, which is dividing when we're multiplying to get x is equal to 7. And if it's x squared equals 9, the opposite of squaring something is that square root. And so we would get x is equal to technically plus or minus 3. So what's the opposite of a sine function? And on the calculator, when you press the trig button, you'll notice that underneath we have these little negative ones. Looks like to the power of negative 1. It's actually called an inverse function. This is the notation for an inverse. So it's the sine inverse, or you might also see it written with arc sine, okay? It's the same thing as sine inverse as writing arc sine. So what we're going to do is take this 1/2, and you can watch, we can take the calculator. If we pick any angle measure that's between 0 and 90, okay? If we take the sine inverse of the sine of that number between 0 and 90 here, we broke something. So let's just type in 42. When we hit enter, we're going to get that 42, okay? And we could change this to anything you want, as long as it's less than 90 and more than 0. How about 63.5, right? We're going to get that 63.5x. So what's happening is the sine and sine inverse are like when you're multiplying divide right by 2 here, are undoing each other like we did on the first part. They're undoing that. So how do we solve it? So what we're going to do is we're going to take the sine inverse of both sides. So we're going to do sine inverse, parentheses, which means of, the sine inverse of sine of x, and we're going to take the sine inverse on the other side. Oops, and it's 1/2. Okay, now what this is actually asking the calculator to do is what angle measure creates a ratio in a right triangle, creates a ratio of 1/2. So remember the sine and sine inverse, these cancel each other out. And then we take our calculator, we press trig, sine inverse, and then we're going to go ahead and type in our 1/2. 1/2. And so what angle makes sides with a ratio of 1/2 in a right triangle? 30 degrees. Okay? So this is just 30 degrees for our angle measure. Okay? So anytime you're solving, okay? Anytime we're solving, we are going to recognize that we want to find the angle measure, and notice that we want to do the inverse. That's the sine to the little -1 thing. So you're either going to see this written as arc sine or sine inverse, okay? It means the exact same thing. It's just a different way to write it, all right? So on the calculator, we're going to type in sine inverse 1/2, and the calculator will give you the angle measure. Okay, let's try it on the next one here. Find the angle measure from the boy to the top of the tree. Now, this question, okay, if this were like find the height, we got to keep in mind that there's a distance here. It doesn't affect our question because we're just looking from the eyes, from his eyes up to the tree. We're just looking for this mystery angle theta here. So we're still going to set this up the exact same way. We're using SOHCAHTOA. First step is to find our reference angle. That's the angle where his eyesight is, with theta is right here. The two sides we're going to label once again are where his opposite, adjacent, hypotenuse. So the opposite side is the tree. The adjacent is the distance between the boy and the tree here, and the hypotenuse is like the distance between the top of the tree here to the boy. So we're looking for create a ratio of these two sides. And since we know with SOHCAHTOA, if we're using opposite and adjacent, we're going to go ahead and use that tangent function. So just like before, we're going to pick our function. Tangent of theta is equal to opposite over adjacent. We're going to plug in. So the tangent of still theta is equal to the opposite, which is 28 over 40, the adjacent. And now to undo the tangent, we're going to take the tangent inverse of both sides. This is like plugging tangent into the tangent inverse function, okay? And all it's saying is what angle measure creates a ratio of these two sides. So these will undo each other, leaving us just the theta. And then we're going to take our calculator, we're going to press trig, tangent inverse, and then we're going to type in our fraction. So 28 over 40. So 28, press Control divide for our fraction bar, over 40. Double check to make sure we have the right function and the inverse there. Oop, and this one is undefined because we put it over 0 instead of 40. Let's go add that 0 in here. Let's add that 4. There we go. So we got 34.99. It says nearest hundredth, and that's going to be our hundredths. So 34.99 is an angle. So we are going to list down just degrees here for that angle. Okay, see if you can try number 2 here. So try this one on your own. So you can pick your function, and we'll work through the rest together. Okay, so for example 2, the first one here, we have our angle A. We also have adjacent 13 and hypotenuse 20, so we're going to choose cosine here, and then we're going to go ahead and plug in. So the cosine of A, 13 over 20, we're going to take the cosine inverse of both sides, so doing the cosine to the -1, the cosine inverse, and then we can use our calculator to get that answer is 49 nearest degree, 49 degrees, because the next one is a 4. So A would equal 49 degrees. For the second question, once again, we have our angle, opposite over hypotenuse. So we're going to use sine here. So sine of angle B is equal to 40 over 42. Take the sine inverse of both sides. Those are going to undo each other, right? The cosine, cosine inverse, sine and sine inverse here. We're going to get B is equal to, and then 72 point, next number is a 2. So it's going to stay at 72 degrees. Okay, so let's see if you guys for homework tonight are going to work on 1 and 2 and 3 here. And for the rest of class, go ahead and work on example 4, and I will post answers in a second. Okay, so for part A here, we're trying to find the vertical distance. So keep in mind that that is this side from the ground to the top of the ladder. So since we're talking about just side lengths, side, side, and side, we actually want to use Pythagorean Theorem. So we can plug in a squared plus b squared equals c squared and do x squared plus 7 squared. Most important thing, remember the ladder is the hypotenuse here. Or we have our formula where we do c squared minus b squared equals a squared. So either square out the 7 and subtract, or you can use this formula. We should get 207 is equal to x squared. And then we're going to go ahead and take the square root of both sides to get our answer. Okay. Now the second one here is actually talking about the measure of the angle. So remember the angle that we're talking about here, and in a second we'll take a look at the square root of 207. This is 14 to the nearest tenth, 14.4. Because remember we're going to take the square root of both sides here. And then the angle that we're trying to find is down here. Okay, the ladder and the ground. So the cosine of our angle is going to equal to 7, which is the adjacent side here, over the hypotenuse, over 16. And then we're going to, since we're looking for the angle, remember we're going to use the inverse, not cross multiply. So cosine of inverse of cosine theta is equal to the cosine inverse of 7 over 16. And then theta is going to equal, oh, that's the wrong button, 64 to the nearest degree. And if you use the 14.4 here, you could have used sine and done sine inverse with the 14.4 over 16, and you would have gotten a little different decimal, but it's the same answer of 64 here. All right, okay, give the last two exercises a try. We'll take a look at them. Just a little warning for number D, a little warning, but just notice since we have all three sides, you could use whatever trig function you want and you should still get the same answer. Okay, try these last two. Okay, so for number one, our reference angle, we have adjacent and the opposite side. So we're going to go ahead and use our tangent function, opposite over adjacent. So tangent of C is equal to 14 over 29. We're going to go ahead and take the tangent inverse of both sides. So that'll leave us with C is equal to, and then we can go ahead and type it into the calculator in a second here, and we'll figure out that answer. Okay, so remember the tangent inverse and tangent are going to drop out. We're going to go ahead and do trig tangent inverse, get in there, and then 14 over 29. And then we're going to round that to the nearest degree, so that would be 26 degrees. The last one, remember we talked about you have whatever choice you want to make here. We'll go ahead and use the opposite and, I don't know, the hypotenuse. So we'll go ahead and use these two for the sine. So the sine of angle D is the opposite leg over the hypotenuse. So the sine of angle D is equal to 68 over 85. And we'll go ahead and check this with the other ones too, just to show that we're going to get the same answer. So the sine inverse of the sine of angle D is just going to leave us with D. And we're going to take the sine inverse of 68 over 85 to figure out our final answer here. So trig sine inverse 68 over 85, enter, and we're going to get 53 degrees here. Okay, had we used cosine, we would have done 51 over 85. So cosine inverse here, and then 51 over 85. Still get that same answer. Okay, and then with the tangent inverse, it's going to be opposite over the adjacent, so 68 over 51, and you see we'll still get the same answer. So won't matter what trig function you use, you should get the same 53 degrees regardless. Okay, you guys are finishing up these last questions for homework, and we'll do some review tomorrow. We'll see you guys later. Have a great rest of your day.